Today, we're going on a journey to what is, without a doubt, the most extreme, remote, and mysterious environment on our entire planet. It's a place of absolutely crushing pressure, total darkness, and near freezing temperatures. Yeah, you guessed it, we are diving deep, all the way to the bottom of the Mariana Trench.
So, first things first, let's just try to get our heads around the scale here. The very deepest part of the trench, this little valley called the Challenger Deep, plunges down to a mind-boggling 10,984 meters. That's almost 11 kilometers or nearly 7 miles straight down.
And to really put that in perspective, picture this. If you could take Mount Everest, the highest point on Earth, and just drop it into the trench, its peak would still be completely underwater. In fact, there'd be over 2 kilometers of water still sitting on top of it. It's just staggering.
Now, all that water creates pressure that's almost impossible to imagine. Down at the bottom, the weight is over 1,000 times what we feel at sea level. The best analogy? It's like having the weight of an entire SUV pressing down on the tip of your finger. It's an environment that, by all logic, should be completely and utterly hostile to life.
And that, of course, brings us to the biggest question of our journey. In a world with that kind of pressure, with zero sunlight, what could possibly live there? For most of history, the answer was just assumed to be nothing. But as we're about to see, the truth is so much more incredible. So before we can really explore the life that calls this abyss home, we gotta understand how this incredible scar on our planet was even created. The story of the trench is one of immense geological forces, a process that's been unfolding for millions and millions of years. It all comes down to this one powerful process called subduction. You see, the Earth's crust isn't one solid piece. It's broken up into these massive tectonic plates that are always on the move. And when two of them collide, one is often forced to slide underneath the other, diving deep down into the Earth's mantle.
And that's exactly what's going on here. The giant Pacific Plate, which happens to be some of the oldest and densest oceanic crust on the planet, we're talking 180 million years old, is smashing into the younger, lighter Mariana Plate. And because it's so ancient, cold, and heavy, the Pacific Plate just bends and plunges steeply downwards, carving out this unbelievably deep gash in the ocean floor.
And let me tell you, this is not a quiet place. The trench itself is this massive 2,550-kilometer-long crescent, and the whole area is just a hotbed of geological activity. You've got the constant grinding of the plates triggering powerful earthquakes, and it fuels this whole chain of underwater volcanoes and hydrothermal vents, which, as we're about to find out, are absolutely critical for life down there. So we know how it was formed, but how did we, as humans, ever manage to reach this seemingly impossible frontier? Well, the story of its exploration is a heck of a journey in itself, starting with a simple weighted rope and leading all the way to high-tech submersibles touching the very bottom of the world.
Our story begins way back in 1875. The crew of the HMS Challenger found a spot so deep their weighted rope just kept spooling out. It actually took until 1951 for another ship to get a truly accurate depth reading using sonar. But the real game changer was 1960, the first time humans ever went down there, followed by these incredible solo and female-led missions decades later.
And here they are, the pioneers who made those dives. Back in 1960, Jacques Piccard and Don Walsh squeezed into the bathyscaphe Trieste, this tiny steel sphere. Their 5-hour descent was, talk about a nail-biter. A viewport window actually cracked under the pressure. Then, more than 50 years later, the director James Cameron made the first ever solo dive. And since then, a new era of exploration has opened up, led by people like Victor Vescovo, and more recently, the Chinese submersible Fenduze.
Now, during their short 20 minutes on the bottom, Piccard and Walsh saw something that absolutely rocked the scientific world. Through their little viewport, caught in the beam of their floodlight, they saw a flatfish, kind of like a flounder, just swimming by. As Piccard later wrote, that one single moment answered a question that had stumped biologists for decades. The deepest, most hostile place on Earth was not dead, it was alive.
That one little fish literally opened up a whole new field of science. So we've arrived at the bottom, let's explore this impossible ecosystem, where life somehow manages to thrive against all odds in what's called the Hadal Zone, named, pretty fittingly, after Hades, the underworld.
So we're back to our big question, but now it's got a whole new layer to it. We know life is there. The question now is, How? Without any sunlight for photosynthesis, what in the world could possibly fuel a food web in this cold, dark, high-pressure world? For a really long time, scientists thought the only energy source was something called marine snow, which is basically a slow, constant drift of organic junk from the sunlight waters thousands of meters above. But what recent expeditions have found is revolutionary. Entire communities of life thriving on a process called chemosynthesis, drawing their energy not from the sun, but from the earth itself. You can think of chemosynthesis as the deep sea version of photosynthesis. Remember those hydrothermal vents we talked about? Well, microbes down there have figured out how to harness the chemical energy from stuff like hydrogen sulfide and methane that's bubbling up from the Earth's crust. They become the foundation of a food web that is completely 100% independent of the sun. It's just amazing. And this unique energy supply supports some truly wild and fascinating creatures. So let's meet some of the locals. First up, the king of the abyss, the Mariana snailfish. This is the deepest living fish ever discovered, and it somehow thrives at depths down to 8,000 meters.
So, how does a creature with a skeleton survive where the pressure should pulverize bone? Well, the snailfish has evolved this incredible set of adaptations. Its body is all soft and gelatinous, so it bends instead of breaking. It's actually lost the genes for heavy bone mineralization, which gives it this flexible, incomplete skull that helps it equalize the pressure. And while it has no need for color vision, it's kept the ability to see in incredibly dim light. Okay, next up is a resident from the very deepest part of the trench, the Challenger Deep itself. This is a type of crustacean called a giant amphipod, and it's one of the key scavengers on the seafloor. Now, this amphipod's survival trick is just wild. Normally, the intense pressure of the deep sea dissolves calcium carbonate, which is what most crustaceans use to build their shells. But this little guy has a different plan. It actually pulls aluminum from the seafloor mud and creates a protective gel to reinforce its exoskeleton. It basically makes itself a suit of aluminum armor.
And if you thought things couldn't get any weirder down there, let me introduce you to this organism, the xenophyphor. It might look like a sponge, maybe a piece of coral, but it is something much, much simpler. Believe it or not, this entire thing is a single cell. I'm going to say that again. A single cell. It's one of the largest single-celled organisms on Earth, growing up to 10 centimeters across, about the size of a mango. And even though it's so simple, it plays this huge role, creating little microhabitats on the seafloor that give shelter to other, smaller critters. But you know, all the life we can actually see is just the tip of the iceberg. Recent projects that analyzed sediment from the trench floor have just uncovered this staggering diversity of microbial life. Researchers have found over 7,500 new types of genomes, and nearly 90% of them were completely unknown to science. The abyss is just teeming with life we can't even see.
And this brings us right up to today. For centuries, the trench was this mythical, unreachable place. But now, not only do we know it's full of unique life, we actually have the technology to go there, and with that ability comes some brand new challenges and pretty heavy responsibilities. It turns out the deep seafloor, especially around these trenches, is rich in rare earth minerals, the kinds of things we need for all our modern technology. And that has sparked a really intense debate about deep-sea mining. As you can see from what scientists are saying, we are right on the verge of potentially destroying entire ecosystems we've only just discovered. So this is the fundamental conflict we're facing. On one hand, there's this incredible potential to access new resources for all our gadgets and green tech. But on the other hand, we risk doing permanent, irreversible damage to one of the last truly pristine wildernesses on the planet, wiping out species and habitats before we even begin to understand them. And here's the really tragic part. Our impact is already there. Even in the most remote place on Earth, we've left our fingerprint. Studies of these amazing giant amphipods from the Challenger Deep have found their bodies are already contaminated with microplastics that have drifted all the way down from the surface. There is literally no part of our planet left untouched by our pollution. Which leaves us with a final, sobering thought to ponder. For pretty much all of human history, the deep ocean was our planet's ultimate mystery, this symbol of a vast, unknown world that was totally beyond our reach. Now that we can finally pull back that curtain and explore its wonders, will our legacy be one of discovery and stewardship? Or are we about to become the single greatest threat to Earth's very last secret?